Hi friends, in this video we'll learn about what is isometric projection, what are the basic characters of it, and introduction to isometric projection as well as isometric view. So let us start with what is isometric projection, where from it is emerged. So we are already aware of it. Projection is nothing but a shadow which is obtained by sending the rays. I hope in the previous videos you are already come across this. So if we consider this particular element, so whenever the object is placed in front of the source of light, the rays will fall on the object, then the rays will travel, those are called projectors. And if there is an obstacle which is considered as the principal plane, so on the obstacle the shadow will fall. This particular shadow is called projection or view. So this information I was given in the previous videos, just go through them, you can able to get it. So here projection is nothing but the shadow or view obtained of a object when the rays will falls over it. Those rays are called projectors. Now, so when it is called isometric projection, I hope you are already aware of this particular classification which was given in my previous videos. So here if you observe where the isometric view will comes under this, so the remaining are not necessary. So let us consider, we will concentrate on isometric projection. Where is that isometric projection? Here if you observe, this particular one is nothing but isometric projection. So here when it is called isometric projection, so this will comes under axonometric, which is a part of, comes under orthographic. So this in orthographic can be obtained whenever it is rays are parallel to each other, and this one is given as a classification of projections. Just in order to know the characters of isometric projection, we have to start from the beginning. So what are those points we have to remember? That is, the observer is at infinite distance. This is the point we have to remember. Observer or source of light is at infinite distance. So in this case the rays are parallel to each other, so we have to remember this word also. That is, projectors are parallel to each other. Whenever the projectors are parallel to each other, depending upon the orientation of the principal plane, means how the principal plane is placed, so these are the projectors. If the principal plane is perpendicular, what it is called, or if the principal plane is inclined, what it is called. If the principal plane is perpendicular to the projectors, then it is called orthographic. If the principal plane is inclined to the projectors, then it comes under oblique projection. But our isometric projection will comes under orthographic. That is why we can able to consider the projectors are perpendicular to the principal plane. The projectors are perpendicular to the principal plane, and it will comes under orthographic projection. Next one is, so in order to get the complete information of an object, there are two ways are there. Let us consider it is an object. It is having the length, height as well as breadth. So in order to get the complete information of it, if the observer is changing his position, then it comes under multi-view projection, which we come across in the previous videos. So but what is another one? In order to get the complete information, observer is not changing. If the object is changing its orientation, now we are going to get the height, length as well as breadth. All these three informations we are getting by changing the orientation of the object. So here object orientation is changes. in order to get the complete information. So then it is considered as whenever object orientation is changing to get the complete information, then it is considered as axonometric projection. What is axonometric projection? So solid will have three axes: length, breadth and height. So if we consider, let us consider it is an object. By changing its orientation, we got the object like this. Now here, let us consider the angle between them are, so here this is the height axis and this one will be the length axis. This one is breadth axis, we are assuming. Now the angle between length and breadth, I am assuming it as alpha. Breadth and height, we are assuming it as beta. Height and length, we are assuming it as gamma. Therefore, the relation between alpha, beta, gamma, we can able to divide it into three axonometric projections. What they are? They are trimetric projection, dimetric projection and isometric projection. So what is the difference between these three? So if these three values alpha, beta, gamma are different, the combination will be infinite. You can able to take any combination, but the sum should be equal to 180 degrees. Why so? So here sum of alpha plus beta plus gamma should be equal to 360 degrees in any case. But if they are different, all these three are different, then it is called trimetric projection. If among them, if alpha, beta, gamma, among these any two values are same, then it is called dimetric. Two values are same, one is different. Therefore, totally how many angles are there? Two angles, one different angle and remaining two are same. It is dimetric. If all these three angles are same, then it is called isometric projection. Just you observe this particular diagram, you can able to get some more clarity. So here, if you observe in this diagram, if you observe here, in the first diagram, one value is 135, another value is 105, third value is 120. These three are different, that's why it is called trimetric projection. In the second diagram, 105, 105 are same, and another one is 150. So there are 105 is one angle, another angle is 150. Therefore, two angles are there, two measurements are there, that's why it is called dimetric. But if you observe the third element, 120 degrees, 120 degrees, 120 degrees. So here all these three values are same, that's why it comes under isometric projection. So in isometric projection, alpha is equal to beta is equal to gamma and it is 120 degrees. So up to now you try to remember these points. In order to get 120 degrees, how we have to change the orientation, we'll discuss in few minutes. So whatever we learned up to now, we'll try to consolidate in a particular sheet. Just you observe this particular, all those things I gave it as a statement. Just have a look into it. So what are the points here? So here, if you observe the characters of this particular isometric projection, what is that? Observer is at infinite distance, just we are consider in the chart, it is already known, and projectors are parallel to each other, and these projectors are perpendicular to the principal plane. So once the projectors are perpendicular to the principal plane, definitely it will comes under orthographic projection. That's why I mentioned the statement as it comes under orthographic projection. It can be obtained by changing the orientation of the object. Just now I said, if the observer is changing its orientation, it will comes under multi-view projection. If the object changes its orientation, then it will comes under multi-view projection. Next one is so object is changing its orientation, that's why the three axes length, breadth, height will be changes. The angle between them will be changes. Depending upon the relation between them, we can able to consider it as isometric. So isometric will comes under axonometric projection, and in isometric projection, three axes of the solid, length, breadth, height, are equally inclined. How much it is? 120 degrees with each other. These are the points we have to remember whenever if you heard the name isometric projection. Good, sir. But how to get this isometric projection? This is also important. So let us consider. So it is an object. This is the front of the object, top, side. These three elements we are there. So this is the front face, top face, side face, height, length, breadth. So when it is called, when we can able to get the three axes will make 120 degrees with each other. Just you observe. This is the front face parallel to the observer. Assume you are the observer. Front face is parallel to you. Top face is perpendicular to the observer. Side face is also perpendicular to the observer. When can we get isometric? Just you observe. This is 90 degrees, 0 degrees. If you are going to rotate like this, these two are equally inclined. Observe, my dear friends. This face is 45 degrees to the observer. This is also inclined to the observer, 45 degrees. Front face and side face are 45 degrees to the observer. Then what it is called? It comes under diametric projection. How, sir? Just you observe this. In this, how we are going to get? This is going to be the height. And here you are getting length. Here you are getting breadth. Here it is 180 degrees, 90 degrees, 90 degrees. So it is one type of diametric projection. But in order to get, this is one type. Diametric maybe so many are there. Among them this is one. So in this one, what happened? Front face is 45 degrees to the observer. Side is also 45 degrees to the observer. Then what about, in order to get isometric projection, what I have to do? So the top face still it is perpendicular. So this one should also be 45 degrees to the observer. 45 degrees to the observer. Then we are going to get isometric projection. So in isometric projection, how we can able to get? All three faces of the solid, principal faces of the solid are equally inclined to the observer. Equally inclined to the observer. Front face is 45 degrees, side face is 45 degrees, top face is also 45 degrees to the observer. Then we are going to get isometric projection. We are going to get isometric projection. So in isometric projection, when we are going to get this isometric projection, one second. In this isometric projection, if you observe, length, breadth, height, all these three axes, height, length, breadth, all these three axes makes 120 degrees with each other. Now when we can able to get all three faces of the solid should make equally inclined to the observer. Sir, I have a doubt. Sir, you are considered a cuboid. You can able to make like this. But once the object is an irregular shape. So let us consider this is one object. It is not in proper shape, sir. It is some irregular, some base is there, wall, some house shape. Then how you have to do? Very simple. You have to enclose this particular object in a cuboid. Bottom one sheet you have to place it. Top one sheet you have to place it. Leftmost one sheet, rightmost one sheet, front another sheet, back another sheet. So you have to enclose, even though the object is not in a cuboidal shape, we have to enclose this particular object in a cuboid element. Then only we can able to go ahead with isometric projection. By assuming all it is placed in a cuboid and we are changing that object such a way that front, top, side, all the faces should make equally inclined to the observer, and that inclination is also 45 degrees. Then only we can able to get isometric projection. Isometric projection. So this word is also important. What is that? All the three faces, what all are the three faces? Front as well as rear, both are same. Top as well as bottom, both are same. Side, left side and right side, all three faces are equally inclined. How much inclination? 45 degrees to the observer or principal plane. Both are same. We will consider to the observer. You can able to consider like this. Then only you can able to get isometric projection. Sir, here I have some more doubt, because some people who are already come across this particular topic, whenever they are going to construct isometric projection, they use it to draw isometric scale. What is that isometric scale and how should we construct it? And these elements we'll try to learn now. So now let us consider, just now I said all these three faces are equally inclined. Just now you have observed, this is the one considered length direction, this is going to be the breadth direction, this is going to be the breadth direction, and this one is going to be the height direction. This is height direction. So these three are going to be like this, or otherwise height direction I am going to consider like this. So here this is length, breadth, and this is going to be the height. Once if you are tilted like this, so here you are going to get the true length of the object here, here. Once if you are going to tilt like this, you are going to get reduced. Breadth is also previously point. Once if you are rotated like this, here we are going to get the length, but it is going to be compressed. How much it is compressed, sir? Sir, once if this line is inclined to HP, but front view is coming parallel to XY line, but reduced. Is it clear? Now length is going to be reduced. Sir, can I take sine 45? Okay, if it is like this, it is okay. But still you are rotated like this. This line is going to be rotates like this. Then how should we consider this, sir? How should we consider this element? So how can we analyze this particular thing, sir? So let us consider, all of you observe this. This is the length. Once if you are going to rotate like this, it will appear as a reduced. Means length is not same. If it is 100 mm, it is going to be reduced. Similarly, previously this is the breadth, but once we are rotated like this, we are going to get this is also reduced. Why, sir? In this case it is true, but it is 45, so it is also reduced, but height is going to be the true. But what I am doing, I am going to rotate like this. So even though previously height is like this, once if you are rotated, it is also reduced. Sir, then how to get how much length we are going to get it in the front view, how much length we will get it in the top view, how much it will appear in the side view? Like length, how much it will appear? If it is 100, how much we have to draw in isometric projection? Breadth is 200, how much we have to draw in isometric? Height is 50, how much we have to draw in isometric? All these things we have to know. So for that we have to consider isometric scale. So before moving on to the isometric scale, here you have to learn one more element. What it is, sir? Here if you observe, let us consider this is the line. Let us consider this line. Now here the angle between length and height is 120 degrees. but once if you consider it is 90, therefore length is making 120 degrees with vertical, that is height line, but with horizontal it is going to make 30 degrees. That is considered as view inclination of the length. What is that? View inclination of the length. Similarly, breadth, how much it is making? Same similar matter. If it is 120 degrees B and H, angle between horizontal and height is going to be 90. Therefore here also we are going to get 30 degrees. So here if you observe, a breadth line is making 30 degrees, height line is also making 30 degrees. But here height line is also, if it is like this, if it is tilted like this, it will appear as vertical only, but how much it is reduced we can't able to get it from this diagram, but from the principle we can able to know it. So for this, if you view from the side view, it is going to rotate for 45 degrees. Then how to get all these, the relation between true lengths to the view lengths, that is projection lengths. So for that, how we have to use? We have to use isometric scale. Isometric scale. What is isometric scale? Majority of you are aware of it. This is called isometric scale. Here with horizontal, true length is making 45 degrees and isometric length is making 30 degrees. Sir, why? Just you observe, my dear friends. So first, if it is the case, now you are rotated like this, then you are rotated. So here if you observe, the length line is top surface is making 45, but it appears as 30. In line inclined to both the planes, I said this particular word, my dear friends. What is that? View inclination and true inclinations are differed. View inclination and true inclinations are not same if it is inclined to both the planes. If it is inclined to both the planes. So here the true inclination is 45. You are rotated only 45. But it is rotated with respect to two principal planes. That's why it appears as 30 degrees only. 30 degrees only. That's why view inclination is 30 degrees. True inclination is 45 degrees. So in order to get how much is the view inclination, that shadow, how much length it will appear. Shadow, how much length will appear. How should I know? So very simple. From this scale we can able to get it. Let us consider AB dash is true length. AB is isometric length. AB is isometric length. Is it clear, my dear friends? So if the true length is some L, then how much is the isometric length? Let us consider true length. I am writing it as TL. Isometric length we are going to consider as IL. So what is the relation between true length and isometric length? Very simple. Just if you have the basic trigonometric, we can able to aware of it. So what it is, I am going to draw one vertical line here, and we are going to assume this particular point as C. Now what is the true length, sir? True length is nothing but A B dash. Isometric length is nothing but AB. Now let us consider for triangle A B dash C and triangle A B C. Base is going to be the same. AC will be the same for both. So from the triangle ABC, I have to know the relation between hypotenuse as well as adjacent side. Therefore how much we are going to get? So from this triangle I am going to consider cos 45. What is cos 45? Cos 45 is nothing but adjacent side divided by hypotenuse, that is AC divided by AB dash. So from the second triangle cos 30 is equal to, what is cos 30? Opposite side, adjacent side by hypotenuse. Adjacent side is AC divided by hypotenuse is AB. So from these two, how we can able to write? From this, AC is equal to AB dash into cos 45. That is, and from another one, from here AC is equal to AB into cos 30. AB into cos 30. These things we are already aware of it. So what about this? Just you observe. What is A dash B dash is true length. Cos 45 is equal to AB is isometric length cos 30. So this one I am going to write here. A dash B dash is nothing but true length into cos 45. And according to this AC is same is equal to isometric length into cos 30. Isometric length into cos 30. Is it clear to all of you, my dear friends? Just you look into it. Now, I hope you all got the idea. Therefore, isometric length into cos 30 is equal to true length into sin 40 cos 45 cos 45. So from this, isometric length is equal to true length into cos 45 degrees divided by cos 30 degrees. Cos 45 degrees divided by cos 30 degrees. What is this value? Just you calculate and check it out. So from these we can able to get isometric length is equal to true length into how much value you are going to get. So what is this value we have to get? So we have to divide. Just I will do the calculation. Normally I won't remember this. So let us consider cos 45 divided by cos 30. How much value you are going to get? 0.8164 So we can able to write 0.8165 we can able to write 65 we can able to write. Therefore how can I can able to write isometric length is equal to 81.65 percentage of true length. 65% of true length. Therefore how much is the reduction, sir? How much is the reduction? How much value we are going to get? So isometric length is reduced by how much length it is reduced by is 81.65 percentage of true length, or in isometric lengths will be reduced by how much percentage? That is 18.35 percentage is the reduction of the length, and among 100 it will appear as 81.65. Normally we can able to, some people may consider it as a 82% also in some places if you observe. So 82% of the true length, but actual thing is 81.65. How much it is reduced? 18.35 is the reduction. So whenever you are going to draw isometric elements, isometric projections from the multi-view projection, so what is that conversions we will discuss in the next video, don't worry. So multi-view projection, we have to do this calculation. Sir, every time doing the calculation is easy? No, that is why we are going to use this particular scale which is considered as isometric scale. Sir, if they given it as a 40 centimeters, I won't take 4 centimeters. From here to here I will measure with the compass and I will mark it on the diagram. If it is given as 25, so from here to here I will measure and I will transfer it. So every time calculation is difficult, that's why we are going to use isometric scale. Sir, in my undergraduation, majority of the times my professor is not informed to convert it, to transfer it, but simply he is saying whatever the length it is there in a multi-view, you transfer it in isometric. But is it true or false? If it is true, whatever the concept you gave, is it wrong? No, both are correct. So in which way, by taking the true lengths are going to be correct? In which fashion, where we have to take this particular length? Remember, my dear friends, sir, everything we are going to reduce by 81.65. So instead of reducing that, one second. Instead of reducing every time, if you are going to take the true dimensions, then what it is called, there is a small difference is there, my dear friends. What is that? Just you observe these particular diagrams. So here the same object is mentioned here. So here if you observe two diagrams, both are same, but size wise, left side diagram is smaller in size, right side diagram is little bit larger in size. So what is this, sir? So whenever you are considering isometric lens, what is that? Isometric lens, that is 81.65% of true length, then the diagram is called isometric projection. So sir, I am not interested to take 81.65% of the true length. No problem. If you are going to take the true length of the object, so if you are going to take true length while drawing the isometric diagram, then it is called isometric view. So remember, my dear friends, isometric projection and isometric view are not same. Isometric projection and isometric view are not same. So if you are transferring actual dimension in isometric, then it is called isometric view. Sometimes it is called isometric drawing. Isometric drawing or isometric view. So here we are taking true dimensions, dimensions or lengths. Is it clear? Similarly, what about isometric projection? Actually, in isometric projection, how much shadow you are going to get as it is you are drawing. Have actual shadow. Projection is nothing but shadow. Actual shadow, if you are going to draw it, then it is called isometric projection. In isometric projection, you are going to get reduced dimensions, not the true dimensions. That is isometric lens you are considering. That is the difference between these two. Now, majority of the people will have a doubt. So now you are already clear. Isometric view is an enlarged diagram of isometric projection. Isometric projection. Isometric projection, it is an enlarged view, is a larger size than projection. Is it clear, my dear friends? Now we have one doubt. How much it is enlarged, sir? All of you carefully observe. Most of the people will be confused here. Isometric length is 81.65% of true length, or isometric length is 18.35% of reduction. It is a reduction. 18.35% of reduction is there. So most of the people, what they think is, sir, isometric view is 18.5% of enlarged. No, it is wrong. Isometric view is not enlarged by 18.35%, my dear friends. It is other than that. Sir, how can you able to know? Just you consider one element. Let us consider. So here in isometric view, what we are going through lens we are considering. In isometric projection, what we are considering? Isometric lens. So let us consider. Isometric view, I am assuming it as true length is 100. This is 81.65. Therefore, how much is enlarged? That is final length minus initial length divided by initial length. So here final length is nothing but true length. Initially, whatever it is there, that is isometric length. Both are same. So final length is 100 minus 81.65 divided by 81.65 into 100. How much it is? Just you calculate, my dear friends. 100 minus 81.65 divided by 81.65. We are going to get it as 22.47%. That is equal to approximately 22.5%. Remember, this is also important. Most of the students will be confused here. Isometric view is an enlarged object of isometric projection. But how much it is enlarged? 22.5. It is not 18.35. 18.35 is the reduction of true length in isometric projection. In isometric projection, true length is reduced by 18.35%. But in isometric view, isometric projection is enlarged by 22.5%. This is important. All of you should remember this in a conceptual wise. Good. Sir, how to convert isometric diagram into multi-view projection? That is front view, top view, side view are given. Then how to convert it into isometric diagram? Those things we'll discuss in the next video.